All right. So today we'll try to, again, we shall start with an introduction. And talk about the things that we offer as Yaaka. Okay. I was seeing something here. Computer fine connected. It is not working well. Let me just switch here. Okay. I got it. Sorry about that. If you can still hear me, please say something, because I was connected on 2 devices. Now I've disconnected one. You guys can still hear me?
Yes, we can hear you well.
Okay, good.
Yes, teacher, we can hear you properly.
All right, that's good. So
yes, we can hear well.
Okay. Again, this lesson is brought to you by Yaaka Digital Network. It's a free class, and these are some of the services we offer, as you can see. Yesterday I went through all of these. Please make sure when I share these notes in the WhatsApp group, you can always share with your parents just for the future. When you guys need to pay, you can always pay. And you always know how to convince your parents to pay, because now you have experienced Yaaka. Okay, very good. So today we'll be looking at the chemical properties of oxygen. Last time, who can remind us what we looked at last time? What did we look at last time? You can raise up your hand and we'll see who remembers. Yes, Elisha.
Yes, teacher. Yeah, teacher.
Yes, Elisha. What did you look at last time?
It's our first time.
Yeah, it's our first time
to be in the class, so
I'm thinking this is the Elisha, you know.
yeah.
Your voice is very familiar. Okay. For the rest of you, Elisha and Joel are my students, so I was wondering how the voice was so familiar, but I couldn't ascertain that. Okay, it's your first time. You're welcome to this lesson. Is there anyone else who was here last time who remembers what we talked about? Okay, so it was still about oxygen, but just a few things about oxygen, the physical properties and how oxygen exists in nature. So today we shall talk about the chemical properties. And the first chemical property we shall look at is the most common property of oxygen, which is about combustion. Oxygen supports burning. Okay, and most metals and non-metals burn in oxygen, forming a basic and acidic oxides. Okay, so that is one of the most prominent properties of oxygen, being able to support combustion. It's very, very prominent because it is how oxygen is basically identified from other gases. For it supports burning, especially with those non-metals and metals. So we shall look at so many reactions of oxygen on how it supports burning. Okay, so here is an example of a word equation between a metal and oxygen. As you can see, a metal here reacts with with oxygen, forming a metallic oxide. Okay. Most of these metallic oxides formed are basic. Right? That is something very important to note. Now, when it is reacting with non-metals, okay, oxygen and non-metals, a non-metallic oxide is formed. And most of these non-metallic oxides are acidic in nature. Okay, so that's how oxygen reacts with metals and non-metals. We shall see more examples as we continue. Okay. So let's start with the reaction of oxygen with metals. Reaction of oxygen with metals right here. So metals burn in oxygen, forming basic oxides, which when dissolved in water form basic or alkaline solutions. These solutions, the reason why we call them alkalines, because they turn red litmus paper to blue, but have no effect on blue litmus paper. So they will turn the red litmus to blue, but when you dip in a blue litmus paper, it remains blue because these are alkaline solutions. Okay. So this is exactly how oxygen reacts with the metals. Please remember, if you have a question, you can always raise up your hand and ask. Maybe when you don't understand something, you ask. Okay, we can continue. Let's look at the first reaction, the reaction of oxygen and magnesium. Reaction of oxygen and magnesium. So magnesium burns in air, which is oxygen, with a very brilliant white flame, forming white ash or white powder. The white ash or white powder is magnesium oxide. Okay, it's magnesium oxide. So the brilliant white flame forming white ash. That's what we observe when magnesium reacts with oxygen. Here is the equation. As we can see on the equation, we have a word equation here, magnesium reacting with oxygen, forming magnesium oxide. And then the symbols, the symbolic equation is right here, magnesium, oxygen, forming magnesium oxide. Remember, your equations have to always be balanced well, so that the reaction is feasible or it's possible. Is there any questions about this so far? Please mute your audio when you join. I don't know this person here, their name is very long and full of letters. Please mute your volume. Okay. So if you don't have any questions, we can continue. So when like we said, when these oxides are dissolved in water, they form alkaline solutions. It's the same thing when you dissolve magnesium oxide. It dissolves slightly in water, forming an alkaline solution of magnesium hydroxide. And here is the equation for this. Okay. Magnesium oxide dissolves in water to form magnesium hydroxide. And this is just the general way oxygen reacts with metals. They form oxides, which oxides dissolve in water to form alkaline solutions. And here we see magnesium reacting with oxygen, forming magnesium oxide, and then magnesium oxide dissolving in water to form magnesium hydroxide. That's the way it works. Okay. The other reaction we can look at is the reaction between sodium and oxygen. Right there. So sodium burns in excess oxygen with a bright yellow flame to form a yellow powder of sodium peroxide. Now, this is when oxygen is in excess. When oxygen is in excess, sodium reacts with oxygen, that excess oxygen, to form sodium peroxide right there. This is how we write sodium peroxide. The sodium peroxide dissolves in water, forming an alkaline solution of sodium hydroxide with evolution of a colorless gas that lights a glowing split. And that gas is always oxygen. That's the characteristic nature of oxygen. However, in limited supply of oxygen, sodium burns with a bright yellow flame to form white solids of sodium oxide. So that's the reaction right here. If we have limited oxygen, we will only form the sodium oxide. And also the sodium oxide can dissolve in water to form sodium hydroxide right there. Okay, so that is the reaction of oxygen with sodium. Okay. Any questions so far? You can pause so that you can ask a question. Just raise up your hand and ask the question. Okay. If there's no question, you can continue. I have a question for you. Let's see who can answer it. Okay. The question is, identify the flame that magnesium burns with in oxygen. Who can tell me the flame that magnesium burns with oxygen? Yes, Sharifa, you have to raise your hand.
Blue flame.
The blue flame. Okay, maybe. Good try, Sharifa. Yes, Michael.
It's a very bright white flame.
Yes, very correct. It is a brilliant white flame. That is correct. Okay. I was trying to see if you guys are paying attention there. So well done. Okay, let's continue on calcium. Calcium also reacts with oxygen. And the way it reacts with oxygen is similar to the rest. We have, it burns in the oxygen with a bright red flame, okay, bright red flame, forming white solids of calcium oxide, okay, white solids of calcium oxide, which when you write the equation, this is calcium oxide. See, the calcium oxide slightly dissolves in cold water, forming an alkaline solution of calcium hydroxide. The calcium hydroxide appears clouded due to the presence of undissolved calcium oxide. So this calcium oxide is only slightly soluble in water. Therefore, the solution will always be cloudy, indicating some undissolved calcium oxide. I have another question for you before we go to potassium. The question is, what is the color of magnesium oxide? What is the color of magnesium oxide? What is the color of magnesium oxide? I want someone who has not said something. Michael, you have said something already. The color of magnesium oxide. Someone is writing on my screen now. The color of magnesium oxide. Stop writing on my screen. You're trying to copy. Let me erase this. Okay. The color of magnesium oxide, who knows? You can raise your hand. Yes, Adeng. Adeng, you can mute your volume and speak. I mean, unmute. Yes, it is white ash, correct. That is correct, Adeng, well done. Okay, good. The color of magnesium oxide is white. Okay, that's good. Let us look at the reaction of potassium with oxygen. The reaction of potassium and oxygen. So potassium burns in oxygen with a lilac flame, which is a purple flame, forming white ash of potassium oxide. Forming white ash of potassium oxide right there. The potassium oxide dissolves in water to form an alkaline solution of potassium hydroxide, which we can see right there. So potassium oxide is more soluble than most of the oxides you have looked at so far, but it forms immediately potassium hydroxide, okay, which is very, very, very important to note. I have another question for us. What is the color of the flame that sodium burns with in oxygen? What is the color of the flame that sodium burns with in oxygen? Yes, Blair.
Bright yellow.
Bright yellow, that is correct. Good job. Well done. That's good. That's very, very good. So here is the reaction of, but yes, I've seen your message, Hope, and it's correct. Yes. You can always read the chats to see some messages that are sent there. I've seen a message from the admin reminding you of a certain lesson, but we can continue. So yeah, this is the reaction of potassium and oxygen forming potassium oxide. The oxide is readily soluble in water, forming potassium hydroxide solution. Very good. Any questions so far? Any questions? Something you've not understood? Okay, very good. We can continue. Let's look at the reaction of oxygen with iron. Oxygen with iron. Oxygen burns in iron. Sorry, that was a typo. With a shower of bright sparks, leaving behind the blue-black solids. Leaving behind blue-black solids. Okay. So this is tri-iron tetraoxide, which are the blue, the black solids. Okay, right there. The oxide of iron formed is insoluble and therefore has no effect on litmus paper. So this is especially when we have a lot of oxygen or excess oxygen. You see, iron is very good at reacting with this oxygen. That's why it forms this complex that we call tri-iron tetraoxide. Okay. When it is not that much, it will form iron 3 oxide, and then when it is very, very little, iron 2 oxide, depending on the oxidation state of that iron. Okay. How do you know the solution is alkaline? Hope is asking a question. Hope that's a good question. How do you know a solution is alkaline? Who can answer that for us? Yes, Nicole. Yes, Nicole, your network is not good.
Your hand is out.
Nicole, your hand is out. You can't tell. All right, mute your volume if you don't have an answer. And your network is disturbing. Who can tell us how do you know a solution is alkaline? I hope is asking a question. Nicole, mute your volume. Nicole, mute your volume. Yes, Bridget, how do you know a solution is alkaline? Nicole, if you can hear us, please mute your sound. It's stealing out ears.
Oh, good. I want to make it
If you're using a phone, swipe left and mute your volume. Okay, Bridget, tell us, how do you know a solution is alkaline?
By the use of litmus paper.
Yes, we use litmus paper. We use litmus paper to tell whether a solution is alkaline or acidic. The litmus paper we use in this case is red litmus paper. It turns blue when the solution is alkaline. And what happens to blue litmus paper when you dip it in an alkaline solution? Who can tell us? If the litmus paper is blue and you dip it in an alkaline solution, what happens to it? Who knows? You can raise up your hand if you know. What happens to blue litmus paper if you dip it in an alkaline solution?
For real.
Is Giovanni going to answer? Because Bridget, you already said something. Yeah, I want Giovanni to answer, not Bridget.
A blue litmus paper turns red.
The blue turns red. Okay, good try. Remember, we're dealing with an alkaline solution. Yes, a book, Christian.
The blue litmus paper does not change meaning.
Yes, very correct. The blue litmus paper does not change or remains the same when you dip it in an alkaline solution. Nicole, you forgot to mute your volume, please. Mute your volume, Nicole. Let me read some other question. All right, yeah, I'll zoom in a little bit for people to see the words. And don't worry, I'm going to send out these notes for you to read and go through in the group. So you shouldn't worry about reading them now. Okay. All right. Finally, someone turned off their volume. Good. Okay. We can continue. We have seen how iron reacts with the oxygen. Okay, good. We can continue. Let's look at copper. How copper reacts with oxygen. So copper metal burns with a blue flame, turning red hot. On cooling, it forms black powder of copper 2 oxide, copper oxide. Okay. At high rate, Sylvia, turn your volume off. Sylvia, turn your volume off, please. Okay, so for copper, we see that an oxide is formed that is black when it's very cold. Okay, when it's cold, it's black because copper, when it's burning, it turns very, very red. Very red, just like the way you see when charcoal is burning, it becomes red. It's the same thing with copper. It is always red hot, but when it cools down, when it cools, this oxide here is black. Okay, copper 2 oxide is black, and that's what you observe. But copper 2 oxide is insoluble in water, and therefore it has no effect on litmus paper. Okay, can only use litmus paper on oxides that can dissolve in water. Copper 2 oxide does not dissolve in water. Okay. Any questions so far? Christine, do you have a question? I'm seeing your hand up. Okay. She had forgotten maybe her hand up. We can continue with lead. Yep, lead. Okay. So for lead, lead melts into a shiny beads and finally forming yellow powder of lead oxide. So when you're heating lead with oxygen, it melts into very shiny beads, which later form a yellow powder of lead 2 oxide. Okay, that's how lead reacts with oxygen. Very good. Now, I have another question for you guys. And the question is, what is the color of iron 3 oxide? Let's do that. The color of iron 3 oxide. Let me see who knows the answer to that. The color of iron 3 oxide, yes, Blair?
A shower of bright sparks leaving blue-black solids.
Okay. That's good. That's a good try. Anyone else? Anyone else want to try? Okay. So iron 3 oxide is brown, right? And iron 2 is green. Okay. Those are the colors. But for the complex we talked about here that is formed in excess oxygen is what Blair has answered, which is blue-black solids. That is the complex that is formed in excess oxygen. Okay, which is tri-iron tetraoxide. Very good. Okay. Let's look at the reactions of oxygen with nonmetals. Reaction of oxygen with nonmetals. Okay. Nonmetals burn in air to form acidic oxides or acidic anhydrides. These oxides dissolve in water to form acidic solutions that turn blue litmus paper red and have no effect on red litmus paper. An acid hydride is an oxide of a nonmetal that dissolves in water to form an acid. We have examples. So here we just basically seeing that when nonmetals react with oxygen, we form acidic oxides. which dissolve to form acidic solutions. The acidic solutions, how we know they are acidic solutions, they turn blue litmus red. An example here is how carbon reacts with oxygen. So carbon burns in oxygen with an orange flame and bright sparks, forming a colorless gas that turns litmus. That turns lime water milky, which is carbon dioxide. So when carbon reacts with oxygen, we form carbon dioxide. Okay, and this is in high supply of oxygen. We form carbon dioxide. You see, carbon dioxide can dissolve in water, okay, to form a weak acid solution of carbonic acid, which is right there. This solution turns blue litmus paper pink, but not red, since it's a weak acid. Okay, so that's the reaction of carbon and oxygen. We form carbon dioxide, which carbon dioxide dissolves in water to form a weak acid of carbonic acid. Questions? If you have any question, please remember to ask. Okay, we can see the reaction with phosphorus. Phosphorus burns in air with a bright yellow flame, forming white clouds or fumes of oxides of phosphorus. The white fumes is a mixture of phosphorus pentaoxide and phosphorus trioxide. So for phosphorus, it forms a couple of oxides, since phosphorus utilizes about 2 valences, okay, 5 and 3. So therefore, when it reacts with oxygen, it will form the first oxide you'll see or observe is mainly phosphorus trioxide. The second one will be phosphorus pentaoxide. And these are white fumes, okay? They're hard to differentiate, but when you test them, you can know exactly that they're different oxides. Phosphorus pentaoxide and phosphorus trioxide dissolve in water, forming phosphoric acid and phosphorus acid, respectively. So the trioxide will form phosphoric acid, and the pentaoxide, the pentaoxide will form phosphoric acid, and then the trioxide will form the phosphorus acid. The one with the less oxidation state will form the weak acid, and the one with the high oxidation state, which is the pentaoxide, will form a strong acid, which is phosphoric acid. Okay. I have a question for us. What happens to red litmus paper when it is dipped in an acidic solution? What happens to red litmus paper when it is dipped in an acidic solution? What happens to red litmus when it is dipped in an acidic solution? Who knows the answer? What happens to red litmus paper when it is dipped in an acidic solution? Who wants to try?
The red litmus turns blue.
Red litmus turns blue. Okay, good
Wait, no.
try.
Stay
Yes, Christian?
The red litmus paper remains red.
That is correct. The red litmus paper remains red. That was a trick question. Okay, most of you said it turns blue, Nope. Remains red because now you're testing an acid. So the red litmus remains red. Acid solutions turn blue litmus paper red, but the red litmus remains red. Okay. So you have to watch out for those trick questions from me. It's very important to watch out. You have to have understood to answer them. Okay, very good. Let's look at the last reaction, which is the reaction with sulfur. Sulfur burns with a bright blue flame, forming cloudy fumes, which have a choking smell. The white fumes is a mixture of sulfur dioxide and sulfur trioxide. Okay, especially when the oxygen is in excess, you always form the trioxide, and when it's a little bit in small amounts, you form the dioxide. These two dissolve in water, forming sulfurous acid and sulfuric acid, respectively. The dioxide, the sulfur dioxide, forms sulfurous acid, which is a weak acid, as you can see in the equation right there. Okay, right here. And the trioxide forms the strong acid, which is sulfuric acid. And that's how the reaction takes place. That's how the reaction takes place. Okay, very good. Lastly, we have the uses of oxygen. Okay. Oxygen is used in living organisms in the process of respiration. It is essential for combustion, to produce heat for various activities. Used in the breathing of as the natural supply of oxygen is insufficient, then, for example, on high altitudes, people flying, in hospitals, like right now, when you suffer from COVID, you have to be put on oxygen. So it's used for breathing, especially for those intense situations. Like when you're flying in these jets, they always put, these fighter jets, they always put a mask on you to breathe in oxygen because you're in a higher altitude. And then when you're in a hospital, like we have said right now, you suffer from COVID, they'll put you on oxygen. You've seen news where oxygen was in less supply in hospitals and people were dying. So it is a very, very, very vital. It's very vital. So oxygen also, when you mix with ethane, produces a very hot flame, which is used in welding. You have seen people who weld different machines. There's a flame that they use in those oxygen tanks, those long tanks. That one is always mixed with ethylene to produce a very strong flame. When you breathe in that one, you might die because ethylene is not good for your lungs. The one that they use in hospitals is a little bit different. It's pure oxygen. The one for welding is a mixture with this ethylene, which is an alkene. So that flame is very hot and helps in welding. Oxygen is also used in the manufacture of steel, the conversion of pig iron to steel. Liquid oxygen is used as fuel in space rockets. And then liquid oxygen can be used in explosives in mines when mixed with charcoal and petrol. So those are the uses of oxygen. And that is today's lesson. I need questions if you have any. Questions if you have not understood something. Again, I'll send out these notes. If you have questions, you can always inbox me. Avoid chatting in the WhatsApp group, or avoid chatting on your personal things and laughing and all that. If you want to have fun, just create another group where you can have fun and enjoy. But the WhatsApp group for Yaaka is only for academic purposes. And that's why I'm going to send these notes for you to go through. And if you have questions, you can always put them in that WhatsApp group also, or you can inbox me. I'll answer them. I'll send out an exercise for you to do later on, since you have, I think, math next. Okay. Thank you for attending. Good job. Thank you for your participation. Enjoy the rest of the day if you don't have any questions. How can you pass chemistry easily? That's the question in the chat box. You can pass chemistry easily if you revise it, okay? If you practice the equations, okay? If you ask a lot of questions to the teacher, you can pass chemistry easily. And also, if you practice the questions, you can pass chemistry easily. Chemistry is not very hard because it is a summary of things. There is no writing paragraph like in history. Okay, it's very easy. So those summaries sometimes can confuse. So it's important for you to always ask the teacher questions when you feel like you're confused to help you pass chemistry easier. So that's a good question, Hope. Feel free to inbox me if you have questions. Feel free to put them in the WhatsApp group. Also, we have a lot of content on the Yaaka website. We have a lot of videos explaining these things in pictures and interactive content. So if you subscribe, you'll even pass chemistry easier because we have so many material to help you. We have questions, question banks, so many things that we have on Yaaka that can help you pass chemistry easier. So that's a good question, Hope. All right. See you later. Enjoy the rest of the day. Enjoy mathematics. Bye-bye.